Hi everyone, this is an example for the quadratic functions and parabolas assignment. Sarah and Lauren are designing a water balloon launcher for a summer project. They're in competition with each other on whose launcher will catapult the water balloon the farthest. The quadratic functions of both their launchers are shown below, where x represents the time in seconds after the balloon is launched, and the output, which is either the f of x or the g of x, is the height of the water balloon in feet above the ground. The first thing we want to do with these formulas, which are in standard form, is we want to convert them into vertex form, and your hint is that each function has a common factor. Just to recall, our vertex form is a parentheses x minus h parentheses squared plus k. In order to transition this standard form to vertex form, we need to complete the square. In order to complete the square, we know that we have to find our c value to add. We also know that our a has to be 1. And for our a to be 1, we know that we're going to group the first two terms in this standard form and take out this negative 0.15. We're going to factor this out of the first two terms, so that way our a is 1, and then we can continue to solve for our c from there. That's our game plan. So again, grouping the first two terms and factoring out this negative 0.15. So I showed that here. I factored it out on the outside, so I took it off of x squared and from 6x. So 6 divided by negative 0.15 gives me a negative 40. So from here, I'm going to complete the square with what's inside the parentheses. My a is 1, my b is negative 40, and I'm trying to find my c. In order to find my c, I'm going to take my b divided by 2 and square it. Negative 40 divided by 2 gives me negative 20, and negative 20 squared gives me 400. So 400 is going to go right after the negative 40x in the parentheses. All right. So here's where we completed the square. We added the 400, but if you're adding something to an equation, we have to offset it. We can't just change the equation. We have to keep it the same equation. So in order, if I'm adding something, I have to then subtract something or offset it in order to not change the value of my equation. All right, so if I'm adding something on the inside, I'm going to have to also continue on and add something on the outside that's going to cancel out with what's on the inside. Now we have to be careful with what we factored out already, because if we were to simplify this down, this would be factored to each term on the inside. So negative 0.15 times 400, I did that here, that's negative 60. So technically, this whole thing here, what I added to my equation was a negative 60. In order to offset the negative 60, I have to then add 60 on the outside of my parentheses of my equation. So again, if this is minus 60 in the end, I'm going to do a plus 60. You have to offset it. So if this is minus, this has to be plus. We have to have this cancel out in the end, so that way we don't change the value of the equation. So now what I'm going to do is I'm going to simplify this, what's outside of the parentheses, for our final answer in vertex form. So we've got f of x equals negative 0.15. We also know this will become x, and it's always, in order to figure out what goes in with the x in the parentheses here, it's going to be the b divided by 2. We did the b divided by 2 up here, so negative 40 divided by 2 gives me negative 20. So x minus 20 squared, okay, because we created that perfect square trinomial, so when we factor it, it's going to be x minus 20 squared, and then we've got the outside we can bring together. Negative 29 plus 60 gives me a positive 31. And here's my answer in vertex form with the H and the K being my vertex. All right, so this is for Sarah's balloon launcher. Now I'm going to do it for Lauren's. All right, here's Lauren's. She's g of x. Again, I want to put this in vertex form, which means I'm going to complete the square. I'm going to group together the first two terms in the standard form, and I want to factor out something in order for a to be 1. And because I've got this negative 0.09 in for my a right now, I'm going to factor that out. So I'm going to take it out of this term and of this term in my parentheses. (2.88) divided by negative 0.09 gives me a negative 32x. All right, so in the parentheses here, my a is 1, my b is negative 32. I don't have my c. I need to figure out what to add after that negative 32. That's what I'm going to be solving for. All right, in order to figure out what to add, my formula is b divided by 2 squared. Negative 32 divided by 2 gives me negative 16. Negative 16 squared gives me 256. All right, so 256 goes in there. So I wrote it out adding the 256. Now what I need to do, because I added something to my equation, I need to offset it so I don't change the value. So I have to consider what I factored out. If I were to factor this back in, 256 times negative 0.09 would give me a negative 23.04. So basically what I did in addition to this equation is I have this negative 23.04 that I added in. I have to offset this. So if that turns into negative 23.04, what I want to do on the outside is add 23.04. So that way in the end this will cancel out and I don't change the value to my equation. So now let's simplify this. Let's factor this. Let's add those things together for our final answer. Okay, in order to factor this out, it's your b divided by 2. We did that up here, negative 16. So we got x minus 16 squared. And then when I add those together, I get plus 27. So here's my vertex form. Again, my h and my k are my vertex. All right, so now I have my vertex form for Sarah and for Lauren. We're going to state the vertex of each function and what does this mean according to the situation. So we know that my h is 20 and my k is 31. I'm pulling out just the h and just the k. In the formula here, we have this negative. It's meant to be in the formula as a minus. So we just want to pull out the h. We want to pull out that positive 20. And in general, guys, whatever you see inside the parentheses here, that sign that you see with the 20, it's always going to be opposite when you pull out the vertex. So if you see this negative 20, if you see this minus 20 in here, your h is a positive 20. If this was a positive in here, if this was a plus, your h would be a negative. So my vertex is a positive 20 and then 31. This is the highest point in my graph. This tells me that when Sarah's launcher throws the water balloon, that water balloon reaches the highest point. Remember, our y value is the height in feet. So the highest point is 31 feet above the ground, and my x is seconds. So at 20 seconds. At 20 seconds, that water balloon is 31 feet above the ground. Same thing for my g of x. So here's my h, here's my k. I'm pulling out these values. I see a negative in there. I'm just pulling out the value of h, which is 16. So my vertex is 16, 27. This means that with Lauren's launcher, that water balloon gets thrown and its highest point is at 27 feet above ground, and it takes 16 seconds to get there. Number 3, compare the a value of f of x to the a value of the parent quadratic function. What effect does this value have on the parabola? So our parent quadratic function is f of x equals x squared. Well, my a value would be a positive 1 in the parent function. For the f of x in our situation here, all the way up here, my a value was the negative 0.15. We know that the a value tells us whether our parabola is opening up or opening down. When a is positive, it's opening up. When a is negative, it's opening down. In the f of x we have a negative a. So we know that our parabola is opening down. We also know that compared to an a of 1, an a of negative 0.15 will also be a stretch. So our graph will be a little bit wider than the parent function's graph. So now, to sketch out both of these functions, the f of x and the g of x, we can take a look at what these water balloons will do. We can see that our f of x, which is in red, this is Sarah's water balloon, goes a little bit higher and it will go a little bit further. Lauren's, you can see in blue, doesn't go as high or as far, even though it's close. So which balloon launcher is better? We would say Sarah's.